All right. We are going to go ahead and get started. Welcome, everybody. We're so glad that you came to join us for our AP review session. And the files that I'm going to be referring to today are all in this folder that I just shared in the link. Both these Steph and I are going to start out on here, and then maybe in like I don't know, 10, 20 minutes, he's going to pop into a breakout room. And so if there's specific questions you want to ask, you can go in there and ask him. Otherwise, I'm going to do a quick rundown on some things. And I'm thinking he'll probably be able to manage the chat a little bit while I'm talking. Sounds good. All right. So I'm going to go ahead and share from my iPad. Maybe. There we go. Okay. So, like I said, we're going to go ahead and just do a quick review, some overview of some basic ground rules. For starters, we have kids, and so they might come on in and say hi or even good night to us. So please be patient if our children pop in here. That's, like extra bonus if you get a little hi and a good luck from our kids. While we're going through things, try to keep yourself muted. If you need to, you can raise your hand, or you can unmute real quick and just say you have a question or something like that. But it's distracting if people have their audio on. And like I said, I'm going to be recording this main room so that way students who aren't able to be in here can go ahead and hold on, let me just minimize my window. I've got so many things going on here. I can't even see what's happening. Um, go away. There we go. Okay. Sorry, I have a lot of stuff going on my screen here. Like I mentioned, everything that I'm going to go through is in this folder, and we are going to go over some different, things. There is a link here which has an overview of all the different topics. And if we open up this link, you'll see a whole boatload of stuff. And I'll come back to this after I go through the things that I already have covered. But that's another piece of material that is available to you. And there are a ton of links in here. A lot of these are links that we've been sharing with you in class. However, maybe you weren't really in the right mindset to need them right then. But so there are lots of goodies all linked in here as well. All right, so let's go ahead and let's talk about what to expect for the AP test. Just in case you forgot all those little basics. So for starters, there's going to be two parts. Each part is 90 minutes each. And there are 90 minutes for 40 multiple choice questions, and they're all worth 1 point. So that means that each question is worth the same. So if you find one to be really hard, just skip it. It is the same amount of points as that other easy question that could be later in the test. And then we're going to have 90 minutes for our 4 free response questions. And again, they are all worth 9 points. Now, if you're doing some fast math, you might be like, that's 36 points. Remember, they scale it to be out of 40. So the multiple choice and the free response are equal weights this year. It's important that as you're going through and doing your problems, that you are skipping problems that involve a lot of code tracing. That's super important because if you are going through and you're like, okay, I know how to do this, and you do a problem. I know how to do this, you do a problem, and then you get to one and you're like, oh my goodness, this is going to take forever. Flag it, come back to it. You want to make sure that you are not burning tons of time on problems that are like very time consuming. All right, so what to expect on our free response. We've gone over this a couple times in class, but just to give you a quick recap, unlike some other AP classes where you never really know what you're going to see, we know for sure that we are going to have 4 questions, and we know exactly what question 1, 2, 3, and 4 are going to look like. And that's great because for example, that you're only going to have one question with the two-dimensional array. Now, with the array and array list, this could involve both array and array list together. You could also see an array up here in this top section. You could be doing some like loop code or things that involve an array, but this question here will be focused on working with and manipulating arrays. And then this one will be focused on the 2D array. And in terms of the different things that we're going to be seeing here, with our class writing question, you're going to have to write a whole class. So you want to make sure that you're comfortable with that anatomy, so to speak, like the class header, your private variables, your constructor. Those are some pretty easy points to get because they're the same every time. It's just a matter of the name of the class and the variables that you're going to see. For the array and array list, you want to make sure, again, some things that are like the basics must have. These are things you need to memorize. How to declare and instantiate your array list, your 2D array. You also must know how to loop through them, how to traverse them, forwards, backwards, every other, how to use a for each loop, how to recognize if a for loop and a for each loop are equivalent. Those are all skills that you want to be super comfortable with. A great way to practice that is CodingBat. CodingBat has a lot of problems with arrays and using loops and going through and doing like wonky things, checking if consecutive elements are the same, trying to find the largest element, all of those really common algorithmic type of thinking problems. All right, so things that we should memorize. With relationship to objects, you want to make sure that you memorize how to declare objects. So for example, we talk a lot about a student class. If I were to say something like, for example, student S equals new student, and then just said Bob, and then let's say the age was 17. Some things that we want to be really comfortable with are knowing that this right here and this is telling me the reference variable type. This right here is the type of object I am creating. And we learned in our inheritance chapter that it's possible that the reference variable and the object aren't the same class. That is okay. But the only way that you can do that would be if the object that you are creating is a more specific type of the reference variable. So you could say, for example, like person S equals new student. And that would work if your code was set up such that a student was a person, which hopefully we all are, right? So that's something that we want to be comfortable with in terms of that. We got to make sure we don't forget that keyword new. New is how we know we've made a new object. And that also tells us what type of object we have made. Another thing that's super important is making all instance data private. And one of the things that we talked about is that another word for these instance data or variables is a field. You might see that used in some places like, the fields are this or the fields are that. That's just another way of saying instance variable, kind of like how we say method and function interchangeably. In terms of strings, there are many methods that you can use. And one of the things they talk about is that when you're writing your FRQ problems, you can use methods that we haven't learned. So like, for example, I'm blanking out on a method that we haven't learned that's not here. But if you knew some, D-Steph, can you think of any off the top of your head?
Starts with.
Sure, there we go. Starts with, at first I thought you were
Just
giving
make
me
sure you're using them correctly. Because if you don't using stuff that we haven't covered, because everything that we've covered so far will get everything done on the test that you need to be able to do.
yeah.
You
They
have to make
say
sure
that
you're using these methods that we didn't teach you correctly.
Yes, they said that every question on the AP test can be solved with things that are in that AP subset. And if you haven't yet played around with it in AP Classroom, you can pull up a copy of the quick reference while you're testing. So while you're doing some of those practice problems, go ahead and give it a go. Try using the tools for like eliminating answers, flagging questions. There's even an option where you can like annotate on the screen and highlight things and make notes. So I would encourage you to use those tools while you're practicing so that way you know how to use them on your test day. All right, so before I continue, I'm going to pause for a sec. D-Steph, can you paste that link again in the chat for anybody who has popped in, the things that we're going over right now, we are going through the Google slideshow, the 259. Oh my goodness, you guys, it has been such a long day. The 2025 AP CSA review slideshow, but there's also a PDF that goes with it. And before I continue, are there any of these string methods that you would like me to go into a little bit more detail on? Going once. Let's see. Anything?
Could you go over the compare to method?
Which one? Can you say that just a little bit louder?
The compare to method.
Yep, you betcha. So substring and compare to. All right, so I'll start with those two, and then if any others come up, then just let me know. You can also throw it in the chat. Okay, so with substring, you'll notice here that there are two different substring methods here, and that's because there's two ways that we can use substring. And I might even, do I have? No, I don't. Okay, that must be on a different document. I have many documents. Okay, so let's say, for example, we said string s equals study hard. All right. And so what you'd want to do is you'd want to start out by, numbering the indices. And we know that our indices start at 0. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that I did put a number on the space because spaces count. Now, if I were to say s dot substring, and I only gave one index, let's say I gave the index number of 4, what that's going to do is that is going to grab from index 4 all the way to the end. So that would equal y, and then I'm just going to put that little symbol for a space. Okay, so so it's going to be y and then space hard. Now on the flip side, if I were to say s dot substring, and let's say I said 2 comma 6, in that case, what that's going to do, there's a couple ways that we could think about this. The first way we could think about it is it starts at index 2 and goes up to, but doesn't include index 6 because that last value is exclusive. You could also think of it like 6 minus 2 equals 4 characters. So I'm going to start at index 2 and then I'm going to take 4 characters. So from index 2, 1, 2, oopsies, that's not my highlighter. We're going to start at index 2 and we'll say 1, 2, 3, 4. And so you'll notice that this is going to give me the string u, d, y, and then the space. So I personally like this subtraction method because then it kind of makes it a little bit easier. You're just saying, okay, this is where I start and I'm taking 4 characters. All right, so with regards to compare to, all right, so compare to allows you to compare two objects. And the most common way that we see this used is with strings. And if you look this up in the Java quick reference, you'll see that there are 3 different integers that it will return. So we're either going to have an integer that is less than 0, equal to 0, or greater than 0. And the way that this works is it refers to whichever object called the compare to. So like it's about a frame of reference. So for example, let's say, D Steph, he's much taller than his children. So if his son was looking at him, he would say, Dad, you're taller than me. But on the flip side, if D Steph was looking at his son, he would say, Jonah, you're shorter than me. It's all about a frame of reference. Okay. So if my string A equals cat and string B equals dog, we know alphabetically that cat comes before dog. Well, the way that Java will do this with strings is it subtracts the ASCII code of the letters. Now, we don't need to know the ASCII code. We don't need to know the number. All we need to know is that it's going to do a subtraction. So if I were to say, for example, A dot compare to B, what that's going to do is that is essentially going to say take A minus B. And I'm going to think of it like C minus D. And since C comes first, you could think of it like it's one letter away, or it would give me -1. If I were to have another string, and we'll say that this one is apple, Okay. A is two letters away from C. So if I were to say, for example, A dot compare to, actually, we'll just make this D so that we're not getting all confused. So if I said A dot compare to D, in this case, I'm doing the C in cat minus the A in apple. And since it's two letters away, that would give me a positive two. You could also think of it like because it comes later in the alphabet, then that letter is so if something comes later in the alphabet or later in order, it's going to be a positive. If it comes first, it's going to be a negative. If the letters happen to be the same, so like let's say it was cat and caramel, then it would compare the C with the C, the A with the A, and then the T and the R. And as soon as it gets to a different letter, then that is the result that gets returned. So we don't care about the actual number that's returned. We just care about the result, whether it is less than, equal to, or greater than zero. DCEF, do you want to add anything to that?
Oh, that's good. I mean, it's
Okay.
again using whenever they mention something staying keeping in alphabetical order, think compare to on the test. Maintaining alphabetical order, you're going to use compare to.
Mm-hmm. All right. So math.random. Ooh, do they love math.random? This shows up in your MCs. This shows up on FRQs. This is definitely something that we need to know. So for starters, math.random by default is going to return a value in the interval of 0 to 1. Notice again that math notation. So the bracket on the 0, the parenthesis on the 1, meaning that the 0 is inclusive. So if I wanted to have, like, let's say, for example, I wanted to get numbers to represent the values of 3 to 8, okay? And I wanted them to be integers. And so if I wanted to be able to have 3, 4, 5, 6, 7, 8, there's actually 6 values here that I could potentially be. Well, if I look at this right here, a lot of times people just say 8 minus 3 and get 5. But if we look over here, there's actually 6 values. Well, when I am including that endpoint, I have to make sure that I remember to do plus 1. So if I'm trying to find a number in this range that is inclusive, to get my range of values, I'm going to do B minus A plus 1. If I'm trying to do it where this is exclusive, then my range of values is just going to be B minus A. And then if I need to offset, meaning I need to start somewhere else, if I need to offset the starting, then I'm going to add that starting value. So to show you what I mean for this example right here, if I want to be able to get an int in the range of 3 to 8, then I'm going to do 8 minus 3 plus 1, which equals 6. So that means I have to say math.random. That's going to give me my value from 0 to 1. I'm going to multiply that by 6. So now I have gone, so think of it like this. If this is 0 to 1, I have multiplied it by 6. So that's going to give me 0 to 6. But I don't want it to start at 0. I want it to start at 3. So I'm going to have to add 3. So right now, this starting value is what I'm adding on. This range is what I'm multiplying. And so now after I add 3, this gives me from 3 to 9. Notice we wanted to go to 8. Well, the way that this works is this is going to generate all those decimals up to but not including 9. So like 8.0, 8.1, 8.35, 8.9999999. And so now when I take this and I cast it as an int, that chops off all those decimals after 8. And that is how I get that random int from 3 to 8. Now, a common mistake when people are working with math.random is they cast it at the wrong point. So there's a lot of ways you can write this correctly. There is pretty much one way that you can take what I have here and write it wrong. And the way that you would write it wrong would be if you put this parenthesis right there. Because what that would do is that would take the value of 0 to 1, cast it to an int, and automatically make it 0. So now we just have 0 times 6 plus 3, which is just 0 plus 3, which is 3 every single time. Nothing random about that. So that is the only way that you can really cast this wrong. So if you're not sure, then just put the parentheses over the whole thing and then cast it when you're done. All right. Any questions so far? All right. D Steph, how about we have you pop in the breakout room and then
I was going to say, I'll move to the breakout room. So if
yep,
anyone has specific questions, you can head in there and we can get those solved for you.
you betcha. All right. So if we take a look at loops, so the things that we have to be careful with for loops is not going out of bounds. And I would encourage you, when we talk about not going out of bounds, I would suggest that you check your first and your last value in your loop. Okay, if we check both the first and the last, then that's going to help you make sure that you're not going out of bounds on the first case, you're not going out of bounds on the last case. When we are checking for consecutive values, I'm going to go ahead and I'm going to erase some of this just to give me a little bit more room here. Okay, when we are checking for consecutive values, that would be like I and I plus 1. So we see this a lot when we're looking at arrays and we're trying to see if you have two values that are the same next to each other, or if you have like if consecutive values are steadily increasing. So if like the index I plus 1 is always greater than the index at I or something like that. So if you're using indexes I or indices I and I plus 1, then you need to make sure that you adjust your for loop. So let me show you what I mean by that. So let's say, for example, I wanted to check if two consecutive values were equal. And let's just say I had an array of integers, we'll just call it ARR. So I can do my for loop. So for int I equals 0. Now the default loop would be I less than ARR dot length and then I plus plus. And then let's say I said if ARRI is equal to ARRI plus 1, then do something. All right, so the problem with this is when we check our edge cases. So, and the edge cases are like the first and the last, right? So when I start at the beginning and I have I equaling 0, that works out fine, no problem. But then when I get to the end and I'm on this last value where my I is equal to my last potential index, and then I go to do this, at that point, I'm going to go out of bounds. And so that's a problem. We don't want to do that. So in this case, what you would do is you would say, okay, I need to adjust my edge case. And instead of going all the way to AR.length, I'm going to go to length minus 1. And so now what that does is that allows me when I'm on, oh my goodness, when I'm on my last value, that allows me to still be able to add 1 to it and not go out of bounds. Similarly, if I were doing I and I minus 1, then I would want to have my first value start at 1. I have a note here that says how to leave a loop early if an action occurs. So typically something like this would happen if you were in a method and you were trying to find something. And so in that case, you would probably just say, return when that action happened. So let's go through the things that we are allowed to do for a for each loop. What is that? Oh, I would love a bite, but can you save it for me, please? Then cut it off. I'm recording. My daughter wants to give me a peanut butter chocolate. You know what? Okay. What is this peanut butter chocolate cheesecake?
No, it's a peanut butter cup cheesecake that Ivy made. Well, that was a big bite.
Oh my god, that's so good.
I know, it's like Oreos and stuff
Oh
on the
my
bottom
God.
with chocolate on the top.
Mm.
She's such a good baker.
Okay. Thank you.
But Dad told me to do this.
That's okay. All right.
Hi. Bye.
That's my daughter, Aubrey. She's a junior. Oh my gosh, you guys, that was so good. Okay. Sorry about that. Okay, so when we can and can't use a for each loop. All right, so let's talk about some of these ground rules here. So for starters, a for each loop, this is also called an enhanced for loop. And a for each loop is really good when you just want to go from beginning to end. Okay, so it's going to start at your first index and it's going to go to the last index. All right, the only way to end early is to break out of the loop or leave the method. Otherwise, it goes from the beginning to the end. Secondly, you don't know the index. So if you care which element you're on, you need to use regular for loop. Another thing that you can't do is you cannot fill an array with a for each loop. You cannot fill an array. And the reason why is because in a for each loop, each iteration creates a temporary variable. So if you are trying to create objects or fill, you're only giving that temporary value the value that you're trying to assign. So nothing's actually staying. It's kind of like if you were taking notes for a big exam and everything you wrote down was on like a post-it note that you crumpled up and threw away. And then you wrote down the next really important thing, crumpled it up and threw it away. You'd be done and you'd go home to see your notes and there'd be nothing because nothing that you wrote down was in a permanent place. And that's the problem with trying to fill an array in a for each loop. It doesn't work. Another thing that you can't do is you cannot remove from an array list. That's also not allowed. So those are the things that we can't do. We also want to be comfortable with being able to write equivalent code in a regular for loop and a for each loop. And I can go through that some more at the end if that's a topic that you guys want me to go through. All right, so other things in the category of what should I memorize? We want to, without a doubt, be able to declare and instantiate arrays. You should have no problems writing that, whether it's an array of integers or an object or strings, it doesn't matter. So let's say, for example, we just had an array of ints, and I said int bracket ARR equals new int 6. So in this case, this is my data type. And when I use the word new, that is what, oops, what did I just do? I don't know. I must hit something. I used to be so good at Zoom and then, well, that was during COVID years. And now I feel like I use it once a year for this. So anyways, sorry. Okay. Anywho, so this creates an array of integers that has a space for 6 integers. And so when we do this, we are actually setting aside space and memory for 6 integers. So think of this almost like a little, I was going to say ice cube tray, but you guys probably don't know what those are. Like a little like bookshelf or ice cube tray or whatever, where I can put integers. And when I start out, this array is initialized with all values of 0. So we want to make sure that we are comfortable with the default values. So when you create an array, default values are 0, 0.0, and false for our primitives, and then null for strings and all objects. And that's really important to know because you have to check for variable values being null when you are working with an array that might not be completely filled. When we do create this array, when we do say new int 6, what happens is there is a variable, I shouldn't say variable, there is a constant that is public for the array that is called length. And so that's why it's arr.length, no parentheses, to access the size of the array. Now, if we were dealing with a 2-dimensional array, so let's say, for example, I had int, and it was a 2D array, I would say bracket, bracket, and I'll just say ARR2D equals new int. And let's say I did 2, 4. Okay. What this is going to do is this is going to create an array that has 2 rows and 4 columns. And so essentially, this is an array of arrays. That is how this is represented in memory. And the reason why this is important to know is because let's say I wanted to grab this entire row. I could just say ARR2D0, and that equals, let me just highlight that, that equals this entire row. I remember we had some FRQ problems where we had to access the whole row of an array, and a lot of students didn't realize they could do that. So that's something that's really cool that we can do. However, let's say I wanted to access the whole column. I can't do that as simply because it's not one unique unit of memory. So if I needed to access a whole column, I have to actually write a loop to go through and access a specific column entry in every single row of my array. So that's just a little tidbit about that. Let's see. So ARR.length is going to give me the number of rows, and that's because this first number is telling me how many elements are in that first spot. And then ARR0.length is telling me the number of columns. And that's because this right here is showing me that I have, if I were to go to the first row and go there and see how big it is, I can see that that is actually an array of 4 elements. And so that's how I get the number of columns. We want to be comfortable with the number, with getting a certain value in the array. And then also we talk here about row major and column major order. So row major means basically going row by row, and column major means going column by column. So it's just a way of traversing the 2D array. And then again, we also want to be able to do a for each loop for a 2D array. And like I said a few minutes ago, in a little bit, I'll run through any syntax you guys want me to clear up for those different things. All right, before I keep going, do we have any quick questions? Okay, so what do we need to know for array lists? We need to know how to declare and instantiate. So when we're working with our array list, we have to say, and you don't have to worry about importing it. Array list, we have to say the data type. And this is in angled, these little like triangle pointy brackets. And then we have to give it a name. So we'll just say names equals, and then again, we're making an object. So we need the keyword new array list. And then you might notice if you look at some older FRQs and whatnot, that they also, again, list this here and then do the parentheses. This right here, this is optional. It used to be required, but now in newer versions of Java, it is optional. So if you don't write that, it is okay. However, you do need to have this, and you do need to have your parentheses. Why do we need the parentheses? Well, because we're calling a constructor, and a constructor is a method, and we need to have the parentheses after the constructor name. Okay, so these are our methods that we want to be comfortable with on our array list. And like we talked about before, you can access all of these methods for strings and array lists and all of that in that quick reference. So if you haven't yet played around with that in AP Classroom, you want to make sure you do that so you're comfortable with how to access it, how to pull it up, where everything is, so that way if you need to use it, you're not trying to find it during the test. These 3 at the bottom that I have highlighted in red, I highlighted them because these 3 return an element. So dot size just tells you how big it is. And we know that with an array list, the size is flexible because it grows and shrinks as you add or remove elements. Dot add, this is going to add an element to the end of the list. This one right here is going to think of it like insert. There is no insert method with an array list, but that's what this one's kind of like. It's imagine, let's say you had like a trilogy of the Harry Potter books, and you had book 1, book 2, book 4, 5, 6, 7. And then somebody was like, oh, I have book 3 for you. You wouldn't put it at the end. No, you'd be like, heck no, I got to put it in order. So you would take these ones and you'd scooch them over, and you would make room for that new book that you wanted to insert in here. And so that's how add works. So when we add something at a specific index, everything after it moves over, so that way we can make room for it. So that's why I said it's like an insert. Set is like a replace. So it is telling me what item I want to replace. So let's say, for example, I don't know, maybe somebody got you the really cool illustrated book for the first Harry Potter book. And so you were going to replace the first one with that. So you would take that one out and you would put the new one in. And then the value that was replaced is actually returned. So I would be able to see, well, what did I return and what was sent back? So that way you could access it if you needed it. Get, just a simple getter, it gets the item at that index, and then remove. So remove takes it out of the list and shifts everything over. So again, let's say we're working on our bookshelf and somebody asks to borrow your book 4, you would take it out, you would give it to them, so you'd return it, and then everything would shift over. And that's because array lists don't have holes in them. They don't have gaps. Everything that's in there is boom, pushed up. If you add something, they scooch over. If you take something out, they scooch in. All right. So the other thing I just want to mention here, in case I don't forget to mention it, is when we are working with array lists, if you need to remove an element, you want to make sure that you either go from the back of the list to the first element, or you want to use a while loop, or if you use a for loop, after you remove the element, then you need to do like I minus minus to redo that index because like we saw when I removed book 4 and those things slide over, you would end up skipping an element and we don't want to do that. All right, so I put a couple of common errors on these next few slides. So let's just take a look at these ones here. So this is a super common error that I see people do. So I'm going to give you just a minute. Let's see, there's 1, 2, 3. So there's 3 common errors here. So go ahead and take a minute and give these a go. I'm going to post in the chat again in case anybody doesn't have access to the documents if you joined late. So, all right. So I just went ahead and shared that. There's a Drive folder and yeah. Okay. So all right. So this first one here, in this case, I've got a string, a title I'm looking for. I have what appears to be a list of these book objects, and the collection is called my library. And I'm saying for every book in my library, I want to get its title and see if it equals the title that I'm searching for. And this code would work sometimes, but not every time. The problem that we see here is I am returning too early. Sorry, my handwriting is terrible. I'm returning too early. I don't want to return right then because otherwise, let's say I was looking for a book called, I don't know, Stella Wins. All right. And let's say I have all of these books on my list, and we'll say that this one here is the book that I'm looking for. And let's say the first one is called, I don't know, Cat. I don't know. And so I check, is Cat equal to Stella Wins? No, it's not. So then I would return false and I wouldn't even continue looking. And what I need to do is I need to check this one and this one and this one. And oh, hey, I found it. Now I should return true. And so what I need to do is I need to take this return false and I need to move it outside of my for loop. So that is a super common error of returning too early. All right, if we look at the next one, here we can see an array of integers, and I am trying to find the average of those integers. And so when we look at this, there are actually a couple errors that are going on here. Does anyone see any of the errors? Yeah, I get it. It's kind of weird on Zoom, right? Okay, so I'll just, answer. So for starters, I never declared sum. I have no idea what it is. I didn't declare it. I didn't initialize it. So I would want to say int sum equals 0. And then now I've added to the sum. And so when I'm all said and done, I have, let's say my sum is, I don't know, 23. And let's say I had 5 values in my array. Well, when I return this, here's what's going to happen. First of all, I have an int divided by an int, which we know is going to truncate. So 23 divided by 5 is going to give me 4. However, I'm returning a double. So what's going to happen is it's going to take 4 and it's going to turn it into a double and it's going to actually return 4.0, which is not what I want. So there are 2 ways that I can solve this problem. One way is I can just say double sum equals 0. And then at that point, when I do sum divided by the length, I have a double value, and double divided by int returns a double. Problem solved. The other way is I can cast sum as a double before I do the division. I can say double sum divided by ARR dot length. And so what that will do is it will treat it as 23.0 and then divided by that length. And then the last thing that I could do is I could say 1.0 times sum divided by ARR dot length. All of those would correctly give me the correct mathematical average. All right, let's see. Last but not least, this is again super common mistake I see students make. We are checking consecutive values, and we have checking if I is equal to I plus 1, those indices. And so, like we talked about in the beginning, we want to check those edge cases. So I look at, well, what's the smallest value I could see? The smallest would be I, which is I equals 0. Valid index. Okay, I checked my minimum. Now let's check my maximum. So on my maximum value here, I'm going to use I plus 1. And when I'm at my greatest value of I and I'm equal to the last index and I add 1, I am going to go out of bounds. And so this is no good. And this is a common error, and it's usually on problems such as this, your FRQ would say something like 1 point for trying with your loop, 1 point for correctly accessing all values without going out of bounds. All right, before I keep going, do you have any other questions? Okay, I know that we talked about random a little bit ago, so I'm gonna skip over this because I thought I had this on the slides. I ended up talking about this already. Same thing with substring. I talked about this already as well. Again, one of those key things I talked about was subtracting the 2 numbers so that you can find the length of the substring. All right, so index and contains. So index of is one of the string methods we want to make sure we know how to use. And basically what it does is it returns the first index, the first occurrence of that string. So in this case, if I have a great, great day, we can see that the word great is listed in there twice. So what it's going to do is it's going to go through and it's going to check, 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 check. And as soon as it finds great, it's going to return the index of that first letter of where it starts, okay? And so since 7 is the index of where the word great starts, that's what it would return. Now, when I use index of and I look for something that doesn't exist, like here I'm looking for X, it's going to return -1 because it's not found. -1 is used a lot when you're trying to find something and you're supposed to return a numerical value, typically a count of how many times it was found or an index of where it's found, because -1 is not possible for an index or a count. That's why it's the default not there or not found. And then the other one that is useful is contains. And we put a note here that contains is not in the subset, but it is helpful. And like we said in the beginning, you can use string methods that are not part of the Java subset. And the subset, again, is just that list of string methods you have to know. They're listed on the Java quick reference that I talked about. But there's so many other methods that if you know how to use them, you're welcome to use them, but you better make sure you use them correctly. Because when you use a method that's not part of the subset and you use it wrong, you might end up losing more points because you might lose like other points along the way for some of that logic. But anyway, so the way that contains work is it's going to return a true or false if the string contains that substring. So index of tells you where it's at. Contains just tells you if it's there. All right, so equals and compare to. We did talk about this a little bit ago, but just a reminder, when we talk about compare to is going to return a value less than 0, equal to 0, or greater than 0. And I'll go back to that in just a second, the question that popped up. So less than 0, equal to 0, greater than 0. And the way that we do that is it's all about frame of reference. So whatever is before the dot, that is the frame of reference, because S1 is the one that is calling the method. So you're saying, I want to compare with this. Do I come first? If I come first, S1, then I return negative. Am I equal to S2? Then I return 0. Am I greater than S2? Then I return a positive. The order of the strings matters. So if I were to go ahead and flip the strings around, then the perspective changes, okay? Like compare my chapstick and my water. Clearly the water is a lot bigger. So I could say, for example, that the water is bigger than the chapstick, or I could say the chapstick is bigger than, or is smaller than the water. Neither one of these objects have changed at all. It's all about the perspective. So whose perspective? So this chapstick looking up at the water is like, "Ooh, you're big." And then the water looking down at the chapstick is like, "Oh, you're tiny," because it's all about the perspective. All right, I just saw a question pop up. Let me take a look at that real quick. So for the previous question, how would you make sure you don't have an index out of bounds? Okay. So, are we talking about for index of, I'm assuming you mean, or are you talking about, yeah, I'm assuming index of. Okay, well, so for starters, index of, if it's not there, it'll return -1. It won't allow you to give something that's out of bounds. The problem where you find the error. Thank you. Okay. This guy. Is this the one? Okay, I think this is the one. Yep. Okay, cool. All right. So what would we do here? So to try to not go out of bounds, we would want to say for int I equals 0, I is less than ARR. And then instead of saying dot length, which is our typical, we would want to say dot length -1. And so what that's going to do is this this -1 makes it so that when I have my +1 right here, I don't go out of bounds. It gives me room to add 1. So that's how I would go ahead and I would fix it. So this would give me happy dance. Okay, that one would work for me. All right, let's go back. Okay, let's talk a little bit about loops. So, like I said a minute ago, many of these loop problems give you 1 point for trying and 1 point for not going out of bounds. No matter what, never ever leave a loop problem blank. Even if you're not sure what to do, just try. Sometimes you'll get that free point, and that's better than leaving a blank. Okay, you shouldn't leave anything blank. So if we have to go from beginning to end, we're going to start at 0, and then we're going to go until arr.length, or if it was an array list, it would be like list dot size. Okay, that's the typical. Oh, I guess I wrote it over here. That's the typical notation for a regular for loop from beginning to the end. Another option is to use this for each loop. And a for each loop is great because it prevents you from going out of bounds. It starts at the beginning, it goes to the end. The time when a for each loop doesn't work is if you have to access consecutive elements or you have to know where that element is located. So in this scenario that I wrote down here, I was just trying to see if the student was in my list. So kind of like if somebody said, hey, is Mike in your class? And you're like, I don't know, let me check the roster. This is me saying for every student in my roster, if the student's name equals Mike, then return Mike. Okay. If I don't have a person named Mike, then when I'm all done, I would return null. Now, you might be wondering, well, why am I returning null here? Why not false or -1? Again, it depends on the purpose of the method. So in this case, my S is a student, and I'm trying to find the student who has whatever part of the name I'm looking for. And when I find the student, I want to return the whole student object. So maybe I was looking for, I needed to get like all of the information for the student. I had to get their address and their email and their ID and all that fun stuff. So once I found them, I wanted to send that student file over. So that's why I need to just send the whole object, all the data that goes with it. But if that student isn't in my class, I have nothing to send. Like, what am I going to do? And because I'm supposed to be returning an object, I have to return something. And so that's where we return null. So in this case, because the code wanted me to return the object, I return null if the object is not found. All right, so continuing on, working with objects, some things to remember. Objects have to be instantiated before you can use them. You have to call their constructor. And the way that we know that we have correctly called the constructor is when we see the word new. That right there, this is my constructor, okay? All of these are calling a constructor. So new, class name, any parameters, got to have the parentheses. All of that is necessary. Arrays and array lists have to be instantiated before they're used. So when we're working with our FRQ problems, you will declare the variable up top and then you will initialize it in your constructor. So let me show you what I mean by that. Like, let's say, for example, I had a class. Trying to find some empty space. I guess I'll just write it over here. So let's say, for example, I had a class and it was public class. And since we were talking about a roster, we'll just say roster. And then I open it up. And then let's say we're going to have an instance variable for the names of all the students. And it was just an array of strings. Then I could say private array list of type string, and we'll just say names. And then inside my constructor, I would say public roster. Then I can say that names equals new array list. And then that would be where I instantiate it. Okay. So this was something that I recall a lot of students doing wrong when we've had these questions in the past on our test. They wanted to put like the equals and all of that up here. And you do not want to do that. That is not where that belongs. So you declare the variable up top and then you instantiate it in the constructor. The only variables that we should give values to up top are static variables. And we'll get to that in a minute. Okay, so this example that I had here, just to recap one more thing, when I am adding an object to an array list, remember an array list can only have objects. So I have to make the object and then add it to the array list. So right here, I am first making the object, and then here I am adding to the array list, or I can do it all in one. This right here is making the object, and then I'm taking that object and adding it to the list. So they both get the job done. All right, common mathematical thing that we'll see is using modulus and division. So remember that modulus is going to find the remainder. So we might see, for example, num percent 2 equals 0. And in that case, we are checking if something is even. So if you're trying to see if anything is divisible by like 5, you do num mod 5 equals 0. So checking if a value is even is a super common task that we're asked to do. Another thing that we're asked to do is to work with the digits of a number. So if we do a number percent 10, that is essentially going to take that number and divide it by 10 and tell me, well, what is left over? And the end result of that is it gives me the value of the ones place. And so that's why this here just gives me the ones place. On the flip side, if I do divide by 10, that is going to remove the ones place because I'm going to divide it by 10. And since it's integer division, I chuck away any remainder and I just get everything but the ones place. Okay. All right. So static variables and methods. We want to remember that static means shared. Okay. It is shared among all instances of the class. It's not unique to any one instance variable. So an instance is an individual, it's a singular object. And a static variable is a variable that every instance can access, can manipulate, change, find out what its value is, but it doesn't belong to any one object. It belongs to the whole class as a group. So if you're trying to access a static method from a class outside the class, the way that we call it is by saying the class name dot method name. We see this a lot with math.pow, math.square root, math.abs. All the math methods are static methods. And the reason why is because we don't need to make a math object to use them. We just call them. When you want to adjust a static variable, remember that all objects share it. They can all see it. They're all able to work with it and so forth. So in this case, some common examples of where we might see a static variable would be the number of students in a class, the next ticket number. That's an example of where you might see that. Another thing to note is with a static variable, this is the only type of variable in a class that we will initialize before the constructor. Okay, so we have to give it an initial value outside of the constructor when we declare that variable. And that's because, again, this variable is independent of any one class. So we have to know that it has a value before any object is even created, because I could have 0 objects, I could have 1,000 objects. It doesn't matter. I still have one static variable. All right, so printing versus returning. So I've been teaching AP, God, I don't even know how long. I've never seen an FRQ with printing. From in this note that I have here, it says there hasn't been any output in over 10 years. And I feel like I wrote that about 4 or 5 years ago. So it's been a long time. You are most likely like 99.4% not going to be, I will answer that question in just a minute, are not going to be able to, you're not going to be asked to print during an FRQ. If you find yourself writing system.out.println in an FRQ, double check it, read it again, and make sure that you are not supposed to return the value. That is typically what they want you to do, is they want you to find a value and return it. So that way the calling program could print it or do whatever it wanted to. All right, let's see. There was a question. Let me just pull that up real quick. Access the static variable by using object.static variable and or class.static variable. So that's a really good question. Since every single object can access the static variable, typically, if you're inside code for the class, right? Like let's say I was talking about this number of students in a class, okay? And let's say I had a variable for the number of students. If I was within the code, any one of those students could access that variable value, like if I was inside that class. But if I was outside of the class, then I would have to use the class name and say the class name dot get whatever that variable value is. So any of the objects can just directly access it because they have access to it. But if I'm outside of the class, then I have to say class name dot and then call a getter for the variable. Does that answer your question? And are there any other questions? You're welcome. Whew. All right, I'm going to pause for a minute and take a breath. Let's see. Do we have to know all the sorting options? Oh, gosh, those sorting options. Okay, so here's what we need to know about sorting. Great question. For starters, we need to know the gist of the different sorting algorithms. So we have selection sort, we have insertion sort, and we have merge sort. All right. The ones that you're most likely to see code on will be the first two. You will not see it in an FRQ. So there will not be sorting in an FRQ. Absolutely not. The way that you will see sorting is you will have, like you might have a sorting algorithm and it might say, which of the following would be the fastest with insertion sort? And it would give you like several different arrays. Things that we would want to know to help you with a problem like that is that you would want to remember that your insertion sort is adaptive. Okay, it only performs shifts or slides if it needs to. So let's say, for example, I had an array like 8, 2, 6, 1, 3, 5. Okay, the way that insertion sort is going to work is it's going to start out assuming that this first value is already sorted. And so it's going to start right here on this 2, and it's going to ask itself, how do I compare to what comes in front of me? Because it knows that the values in front of it are already sorted. And it's going to check and it's going to say, okay, 8 is bigger than 2. So 8 needs to scooch over. So the 8 is going to scooch over. And then it's going to check, okay, what value is in front of the 8? And it's going to find out, oh, there is nothing in front of the 8. So then that's how it knows that this value gets inserted right here. And so now my values will be 2, 8, 6, 1, 3, 5. So even though it kind of looks like a swap, it wasn't a swap, it was a slide. Now I get to the 6, and then the 6 compares itself to the value in front of it. 8 is bigger than 6, so 8 is going to slide over. Now it checks the one in front of that. 2. 2 is not bigger than 6, so that tells it, oh, this is where I insert myself. And so now my algorithm is going to be 2, 6, 8, 1, 3, 5. And now I know that all of those values are sorted. So as I'm going through and doing this, you want to be thinking in your head, what kind of loops are making this happen? And so the outer process where I'm putting these dots, that's my for loop. And my for loop is saying start at index 1 and go until the end. And systematically, every single value, scooch it in where it belongs in that sorted sublist in front of it. But like when I get here to this number 1 and I say, okay, well, 8 is bigger. So 8 slides down. 6 is bigger than 1. 6 slides down. 2 is bigger than 1. 2 slides down. There's nothing in front of me. So since there's nothing in front of me, this is where I insert. And then now I'm going to have 1, 2, 6, 8, 3, 5. Now, as I'm going through and doing this, you'll notice that if this is where I started, this is how it looked after 1 iteration of the outer loop, after 2, after 3. So some of the ways that they'll test you on your sorting algorithms is they'll say, for example, what does the array look like after 3 passes of the outer loop? Because they know that you know how to put the numbers in order, right? They want to know, do you know what it looks like along the way? Now, if you are asked to do a problem like that with insertion sort, there's actually some fun tricks you can use because we know that insertion sort is just going to do one number at a time. And so when I'm looking for the after 3 passes, that just means I just have to sort the first 4 numbers because after 3 passes, I know the first 4 numbers and 3 plus 1 are sorted with respect to themselves. So then you can just say, okay, it's going to be 1, 2, 6, 8, and then the 3, 5. Or you can just quickly walk through it like I did there. So things that we need to know for this loop, we need to know that the outer is a for loop and it starts at 1 and it goes until the end. And then the inner is a while loop. And this while loop has 2 conditions involved. The first condition is making sure it doesn't go like beyond the first. So like you'll notice that there was 2 different times in this code tracing where I had to insert the value in the very front, but I needed to make sure that I didn't go like in the negatives. So it has to make sure that there are still values to check. So I'm just going to say, while there are more and it's greater. Now, again, this is pseudocode. You guys have the actual code in your notes. But this is when I say you don't have to memorize it, what I mean is that you want to understand the logic. And so while there are more values and it is greater, we are going to slide it over. We're going to slide it over and then we're going to check the one in front of it. If that's good, slide it over, check the one in front of it. And then once we're all done doing that, then we are going to insert the value and then we go on to the next one. Now, in contrast to that, we have our selection sort. And with selection sort, this one is a little bit different. For starters, it is not adaptive. Okay, so that is one of the, it makes it a little bit slower. So this is non-adaptive. And the way that selection sort works is it essentially goes through and it goes and it checks every single value trying to find a certain item, swaps it to that first spot. And then it repeats the same thing with the remaining values, swaps it to the next spot and keeps on going through. So if I took this same array of values, 8, 2, 6, 1, 3, 5, first time through, I'm trying to find the value that's going to go here. So I look for the smallest value, which is the 1. These 2 are going to swap. So then I will have 1 and 8, and everything else will stay the same around them. Now, what's different about selection sort is that once I've done that, this value is never going to move. It's done. Okay. So now I go ahead and I do the same thing, but now I'm on this value and I look and I check every value around. And 2 is actually the smallest. So selection sort, it's kind of silly. It's going to swap with itself. That actually counts as an iteration. So now I'm going to have 1, 2, 6, 8, 3, 5. And I'm going to encourage you when you're doing problems like this that you rewrite it again if nothing changes, because otherwise you're going to get off on which line you are at if it's asking what it looks like after X number of iterations. Okay. So now I am on this guy and I look for the smallest, which is the 3. So then I'm going to have 1, 2, 3, 8, 5, and so on. And now these first 3 values are sorted. So in this case, so some things that are different. So within selection sort, after n passes, the first n values are fully sorted. Okay, so after I went through and I did 3 passes of that outer loop, the first 3 positions were purposely where they needed to go. On the other hand, with insertion sort, after n passes, the first n plus 1 values are sorted with respect to themselves. So what do I mean? I mean that like we can see here, we have this 6 is just, or this 3 is just chilling over here. That 3 doesn't belong there, but the first n plus 1 of the first 4 values are sorted with respect to themselves. So those 4 cards have been ordered. Those 4 numbers have been ordered. Now, in terms of the Pseudocode for this selection sort. Selection sort is going to have a double for loop. And the outer for loop is going to start at 0, and it's going to go until I is less than ARR dot length -1. And the reason why it does that is because once we get to the very end, the last value, there's nothing left. So it's already sorted. And then my inner loop is going to go for j equaling I plus 1, and that's going to go all the way to the end. And then what it's going to do is it's going to check, and it's going to say if, in this case, I'm trying to do getting larger. So if the value is smaller, I'm going to update a temp. And then at the very end, I'm going to do a swap. And we should know that a swap involves 3 lines of code. And we're going to say I want to take my one value and save it in a temp. And then I'm going to take that temp and I'm going to copy it over, and then the other value and copy it over there. So we're basically going to take 3 lines of code to go ahead and do that swap. And then last but not least, our merge sort. What you want to know with that is you want to recognize it's going to take your code and it's going to systematically keep breaking it in half and then put those values back together. Let's see. Does the first line that's swapped in selection sort count towards after 1, after 2? So within selection sort, this right here, great question. I'm going to take these. And if we were to apply that over here, it would look like this. So that first line is how it looks when it starts. And then that next line is how it looks after 1 iteration, after 2, after 3. All right, let's see. What other questions do we have? Let's see. When iterating through an array using a for each loop, why doesn't assigning elements to values in this loop reflect permanently on the actual array? Okay, so let me go ahead and answer that. And then Krishna, there will not be a recursion on the FRQ. You will only see recursion on multiple choice. Okay, so let's talk about for each loops. All right, so there's 2 different ways that we see for each loops, and we take a look at how they would be potentially changing the values in the array. So the first one is, let's just say we had an array of integers. And so let's say we had int, we'll call it ARR, and then I'm just going to use this initializer list because it's way faster. All right, so now I have my my array, and then let's say I had a for loop, and let's say I wanted to just double every value. And I said for int a in ARR, I want to do a times equals 2. Okay, so in this case, what's happening is we know that ARR is pointing to a place in memory where I have the values 2, 3, 6, 7, and 8. Now, in this for each loop, what's happening as I'm writing this is I'm going to make my temp variable A. So A is this temporary place, and each iteration through. So right now, I'm right here. A is going to equal that value. So I'm going to copy in 2. Then I'm going to double it. So now A is equal to 4. Now I have finished that iteration, and now I am on to another one. So now I make a new variable A, and I copy in the value 3, and then I double it. And so you'll notice that all I'm changing is a copy. This is like if I passed out a whole bunch of papers in class and you wrote on your copy, you didn't change my copy, you just wrote on your copy. Now, on the other hand, let's say we had an array of objects. So let's say I had an object, we'll just call them, I don't know, or no, we'll go with students. Students are pretty standard. So we'll say student array, we'll call it, we'll say period 7 equals new student 28. And then let's just say I filled the array. Okay. So the array is filled with my roster. There are 28 students and they are all students. And each of these students has a name and an age. Okay. And let's say I wanted to have everybody have a birthday, because why not? Let's have a huge party. Everyone has a birthday. Fun, fun, fun. So I could say for each student S in period 7. And then let's say I wanted to add one to everybody's age. So for starters, I can't just say S dot get age plus plus because that's not going to change anything. I would have to say S dot set age and then S dot get age plus 1, assuming that these methods exist. Okay. I could also have a method that's called have birthday, but we'll just assume that I don't. So in this scenario, if I had something like this, here's what's happening differently in memory. So I have this array period 7. So I say period 7, and it's pointing to this array. And I'm just going to draw it like that. Okay. And we'll say that student 1 is Mila. And I'm just going to guess you're 16. I don't really know. So we'll say student 1 is Mila with 16. And then we'll say Arush. We'll say you're also 16. Who knows? Okay. And then we'll say, I don't know, Dev, and we'll say 17. All right. So now as I go through and I run this code, here's what's happening differently. When I get to this temp variable S, S is a student reference variable. So it is pointing to the same place. So when I say S dot get age and then or S dot set age and then S dot get age plus 1, it is literally going to go here and it's going to say, all right, S, go here, get the age 16, add 1, 17, set that age right here. And so now it's going to go ahead and it's going to replace this with 17. And then now that round is done. So that temp variable is gone. And now I make another temp variable. And S now points right here. And I'm going to say, okay, I'm going to go and I'm going to follow S. I'm going to go here, age is 16, add 1. Now I'm going to be 17. The round is done. This disappears. And so essentially what's happening is even though S only lasts for one round of the for each loop, when I went into the address and actually changed the memory, that change lasts. Does that make sense? Cool. You're welcome. All right. What other questions do we have? All right, I'm going to pause for a sec. I'm going to stop screen sharing and I'm just going to point out a few things that are in my um, folder of documents. Because I know some of you came in after I walked through some of this stuff. Okay. All right, so for starters, just in case you came in, I know I feel like I've pasted this link in the chat a million times, but just in case you happened to pop in here afterwards, this link takes you to this folder and there is a whole bunch of goodies in here. So for starters, this right here, this Zoom overview, it just has like links to all the different documents in here talking about the different things that we're going to see. If you have yet to play around with this JuiceMind or this CSA awesome site, those are some really good resources to get some good like comprehensive review. So for starters, this JuiceMind site, and you guys are going to have to let me know if you can't access it because I was playing around with it with my students and I think they were all able to access it, but that might be because I made them a class and I don't know. I see it differently than you guys do. But there's AI graded FRQs on here, which is pretty cool. I don't know how accurate they are, but if you click on one of them, for example, what it will do is it will bring you in the problem and it will allow you to see the problem and then type your code in here. I don't know if anybody can let me know if you can see this and access this. I'm not quite sure what you guys see on your end. So there's that. That's one thing that I wanted to point out. Another thing is this CS Awesome site. And this is a an online Java course essentially. Some schools use this as their AP curriculum. And so all of the different units are broken down here. These are some practice units. There's like literally practice problems, notes, everything for every section. So if there's a certain area that you're still really struggling with, this might be a great place to look. You can just, go on the screen and just type in Control F. So let's say, for example, I typed in substring, I can go right to it. Or let's say I wanted to type in inheritance, it'll take me right there. So Control F allows you to just real quickly find something. So that might be helpful. Another thing that is in this folder, and I went through this with my classes today, but this one right here that says study guide, what I did was I went ahead and I fed ChatGPT the last 4 years of AP FRQs and the rubrics and asked it to give me like a study guide and talk about common errors. And so that's what this is referring to. So this might be a nice little just take a look at and make sure you've got everything covered. Let's see. Another one is this guy right here, this FRQ tips. And I know we went over this in class, but again, might have been a while ago. Maybe you weren't in the right mindset to hear it. This has examples of the syntax for everything that you need to know. So this could be a really good study sheet to help make sure you're good for that. And then this overview of topics. This file right here, again, just has a little bit of everything. So this is kind of summarizing a lot of the things that we talked about today, a lot of code examples, different things here. And I also put in here some practice tests that I had access to. So these were from one of the books that I had, and I just scanned in the practice tests. So those are in there. And then this FRQ test folder has digital copies of all of the APs from like the last 20 years, just the FRQs. So these are the ones from the last 4 years. And then, oh wait, hold on, this is everything, not just the last 4 years. Well, anyway, they're all in here. Apparently I put them in the wrong folder, but they're all in there. So you can find them in there. Okay, what other questions do you guys have? Anything at all? Yep, I can send the link. All right. There you go. Oh, wait, that just went. Oh, sorry. All right, there we go. Like I said, I used to be really good at this whole Zoom thing, and then it's been a while since I've used it. So sorry, I was sending the chat to the same person over and over. He's probably like, okay, I get it already. All right, what else? Other questions? All right, I'm gonna go ahead and I'm gonna stop the recording.